This video is a part of an application process to become a tech fellow at CodePath organization. Starting now, prompt 1. Imagine you are in a breakout room and a student asks you to answer a question that you do not know answer to. What would I do? First of all, I would acknowledge the question. Only when I have the clear understanding of the question can I give the appropriate answer. And this would be my first step. After that, if I don't know the answer to the question, I would clearly specify with a good honesty that I do not know the answer to this question and that I can give the appropriate explanation after I've researched the question. Building on that, I would utilize all the available sources such as instructor slides or online resources at my disposal so that I can answer the question. This way, the students get an idea of how I walk through the question to give and or to produce the answer when I'm not even aware of what the question is. This way, they get familiarized with the process of thinking. Lastly, I would encourage brainstorming to the group so that they don't get easy solutions and that I can get them back in the next lecture with the appropriate explanation. I remember in my technical interview course that I took earlier on, the tech fellow in our group couldn't answer one of the questions, but made sure that they answer it later. I found this technique pretty good, and we did get our answer eventually. So that's not a problem. I would utilize the same strategy here. So that's how I'm going to tackle this challenge present. Moving on to prompt 2. It is week 3 of class. You have joined a pod during a breakout session with about 5 students in the room. All the cameras are off and there is no active participation. How would you encourage engagement within your pod and facilitate discussion? Firstly, me being a tech fellow would ensure that my video is on and that I am pretty active with the students. I would start by introducing myself and invite others to do the same so that it creates a welcoming environment for the students so that they can also get to know each of the teammates they're going to work for during the 10-week long period. After they know each other, the second strategy would be to play icebreaker games. One of the icebreaker games I used to play was Scribble. That get us all talking, it's just easy. After we have got to know each other, and that the cameras would be on eventually, I hope so. We would focus on problem solving so that they get an idea of how they're going to progress this course moving on. If any of these strategies don't work, my last resort would be to mention the course policies, which is to keep the video and audio on so that they get the attendance done. I would also make sure that they get to know that these policies are for their own good and that they would progress in this course only if they interact properly and learn each and every process. Eventually, they will learn from their teammates different strategies and how to tackle different questions and even learn a different styles of encountering different problems. After all, this is an interview course. You have to get talking. Otherwise, no employer is going to employ you. Now, finally, prompt 3, technical prompt. Imagine you are helping a student in a breakout room. Explain to them how to use the binary search algorithm to find an item in a sorted array. Your answer should provide the target number and it's indexed. If the item is not in the array, return -1. You can use Python or Java in your explanation. So first of all, we'll understand what binary search algorithm is. So binary search is an algorithm that gets you the specific element that you are searching for. Now, as requested here, we have to return the index as well as the specific element or the target element you're looking for. Uh, Now, I'll just give you an idea of how are we going to move through or how are we going to tackle this problem. So take this array for an example. This is a shuffled one. The binary search algorithm only works when the array is completely sorted. So the first step would be to sort the array. So here I have sorted the array. The next step would be we would use two-pointer method left and right so that we can find the middle element using floor division. Here we have found out the middle element to be 5. Now we compare the middle element to the target element, which is 9. Now 5 is less than 9. So we cancel out all the elements before 5 and including 5. Now the left uh, pointer becomes 6 and the right pointer stays the same. It's 10. Now the middle element is 8. 8 is again less than 9. So we reduce the number of elements and cancel out all the elements before 8. So now we are left with only 3 elements. Again, we change the left pointer and we change it to 8 and the right pointer stays the same. Now the index of the middle element is 9. It's 8, so the element is 9. Now the element we are searching for, the target element and the middle element is the same. So we've got the index, right? So here's when we'll print out the index and the target element. Now what if you don't find the element? We'll simply return -1. Now here's the plan for uh, the algorithm that we are gonna work for. I have also included this in the code we are gonna write. Just we'll build on the code here. So I'll first initialize the left element, which would be 0. So yeah, it was 0. Then we'll initialize the right pointer, which should be length of the array -1, correct again. Then we have to do a while loop, which should be something like this. The left index should always be less than the right index. Now we have to find the mid, which is the middle element's index. So this is how are we going to do that? We are going to use the floor division. We're going to sum the left and right pointer first. Do that just right now. And then complete the floor division. This is how we get the mid element. Now, if the element at the mid index matches with the target element, we simply print out the index. Equal to target, return mid, array mid. If mid. Now, in this specific example, our array mid was less than that of the target element, right? So we'll consider the less than target. What are we gonna do? We are gonna change. Oh, sorry. This is pretty good. We're gonna change the left to mid +1. Yeah. Then else. Probably. Oh. Ah, it's all sorted out. Great. So yeah, and now finally we return -1. There's no matches. Yeah, now I'm gonna check if we adhere to the plan. First, I declare the definition, then I sort the array, then I declare the 2 pointers. The left one would be the starting index 0, and the right index would be the last index. Then we check if the left index or the pointer is actually less than the right index. Then we go on. This is the comparison, and then we return this. Okay, perfect. Now we go ahead and run this algorithm. And yes, it works. So 0 is the index, 1 is the target number, 8 is the index, 9 is the target number, and if there's no element found, say, oh, yeah, if there's no element found, we get -1. Check it again. It works, yes. Now this is how we implement binary search algorithm. Finally, We also check the big O analysis of this algorithm. The average performance, the big O analysis would be O of log of n because we reduce the number of operations by half as soon as we eliminate the number of elements to the left or the right side of the middle element. So the average performance would be that, and these are all the possible scenarios. So this is it. I hope that I become a tech fellow and I get to guide all the students. Thank you.